Assalamu alaikum everyone. This is me Sayyida Yamna Imam from Group Cooper. In this video presentation, I will talk about IP fragmentation in TCP/IP sliding window. So let's move on to our topic. What is TCP/IP sliding window? A TCP window is the amount of unacknowledged data a sender can send on a particular connection before it gets an acknowledgement back from the receiver that it has received some of the data. Sliding windows is a technique also known as windowing is used by the Internet Transmission Control Protocol TCP as a method of controlling the flow of packets between two computers or network hosts. TCP requires that all transmitted data be acknowledged by the receiving host. Sliding windows is a method by which multiple packets of data can be affirmed with a single acknowledgement. The TCP sliding window determines the number of unacknowledged bytes that one system can send to another. Two factors determine the value of an unacknowledged bytes: the size of the send buffer on the sending system, the size and available space in the receive buffer on the receiving system. Windows announcements are sent by the receiving system to the transmitting system in order to acknowledge data received as well as to inform the transmitting system of the current buffer size. If a window size of 0 is reported, the transmitting system must wait for an acknowledgement before sending the next chunk of data. If the receiving system reports that the buffer size is larger than the size of a single data packet, the transmitting system knows that it can send multiple chunks of data before waiting for an acknowledgement. Transmitting multiple data packets between acknowledgements allows the data to be transferred faster and more efficiently than if an acknowledgement must be received prior to each transmission. What is IP fragmentation? IP fragmentation is the process of breaking up a single Internet Protocol IP datagram into multiple packets of smaller size. Every network link has a characteristic size of messages that may be transmitted, called the maximum transmission unit (MTU). To fragment a long internet packet, a router creates a new IP packet and copies the contents of the IP header fields from the long packet into the new IP header. The data of the long packet is then divided into two portions on a 8-byte boundary so that the first packet is less than the MTU of the outgoing interface. The more fragments flag MF is the first packet is set to 1. The more flag may already be set in this packet if it has already been fragmented by another system. This packet is fragmented. The second created new packet is then processed. The packet header field is identical to that of the original packet. The same value of the packet ID, the total length field, the more fragments flag MF, and the fragment offset field is the original packet. The packet header field is updated with a new offset field by adding the number of payload bytes sent in the first fragment. If this new packet is larger than the allowed link MTU, the packet is again fragmented. Thank you.